The next recursive function we'll be looking at is sum of subsets. It's pretty similar to print subsequences, but instead of printing all of them, we're going to add all the numbers together and print them to the console. To solve this, we pretty much have three steps. First, we start at the last element, then we add the current element to the subset list, and then we add the current element to each subset in the list. So let's go over these two examples. When we start off, we have an empty list, and we're going to start at our last element. So here we have 7. If there are no other elements in the array, then we can just add it and move on to the next one. So we added 7, now we're on 5. Let's add 5 to our list, 5. And now let's check if we have anything else inside of the list. We do, we have one other element. So what we're going to do is we're going to add the current number we're checking, which is 5, to everything in the list. So because we only have one other element, 7, this is simple, it's just 5 plus 7. So the next element would be 12. Let's look at this example now. We have 1, 2, and 3. So again, let's start at the last element. So let's add 3. There's nothing else in our list yet, so let's move on to the next element. Now let's add 2. So comma 2. Is there anything else in the list? Yes, there is. So let's add 2 to the other element. So we'll add 2 to 3. So now we're going to get 5. And now let's look at element 1. Element 1. Now let's add 1 to each one of these subsets. So first we're going to do 1 plus 3, which is 4. And then we're going to do 1 plus 2, which is 3, and then 1 plus 5, which is 6. And these are all the sums of the subsets for 1, 2, and 3. Now let's write the prototype for this function. Let's go in the H file, and let's write out void sum of subsets, and then we're going to take in a integer array. We're going to take in the size of the array. Then we'll take in the current index. And then lastly, we'll add the running sum. So we'll do int, and we'll say current sum. Now let's copy this and put it in our .c file. This recursive function is going to have two recursive calls. The first recursive call will just add our current number to our list of subsets. So for example, in this scenario, like how we added 3, 2, and 1. And then the second scenario is when we're adding it to all the other sums of the subsets in the list. We're going to call sum of subsets. We're going to pass in the array and the size. These are not going to change. And then let's increment current index by 1 to move to the next index. And then we'll write current sum. This action here will help it crawl all the way to the end. And then once we hit the end, we'll hit the base case, and we'll start doing the operations from there. Now we'll add the recursive call when we want to add the current element to every single item in the array. This is pretty simple. All we have to do is write sum of subsets, pass in the array and the size. Again, these will never change. And then we're going to increment current index by 1. And then we'll add the current running sum with the current array value. So let's write current sum, and then we'll add array at current index. This will call the function again with our current index added to the running sum. So now we just need to add our base cases. Let's go back to the top and let's write if current index is equal to the size. Let's print out the current sum, %d, current sum, and then let's return here so we don't continue on with the loop. Let's go into our main function now. In our main function, I already wrote out all of our test cases. We have 1, 2, 3, 5, and 7, and 4, and then it should show us the result from our recursive function. So let's save this and let's run Control F5 to see what we get. Sum of subsets, we have 0, 3, 2, 5, 1, 4, 3, 6, that's correct. For 5 and 7, we have 0, 7, 5, and 12, and then we have 0 and 4. You might have noticed that we also have 0 here in the result. This is because just like the question before where we're printing out the subsets of a string, an empty string still counts as a subset. Just like in our numbers array, a subset of 0, which is nothing added to it, still counts as a valid subset in our list of subsets. With these test cases, we can confirm that our function is working as expected.